In this video, we'll be going over remove duplicates from sorted lists. Given the head of a sorted linked list, delete all duplicates such that each element appear only once. Return the linked list sorted as well. So for example, we have 1, 1, and 2. 1 and 1 is duplicates, so we only want to keep one of them. So we get resulting list as 1 and 2. Let's go over the thought process. The input list is sorted. This means all of the duplicate nodes are grouped together. For each of the node x, we can check if x is a duplicate node by comparing with the next node, which is x.next. Then if x.val is equal to x.next.val, we will want to skip all of the nodes with x.val until we reach the last node. We will be appending the last node to our resulting list. So for example, if we currently have 1 and 1, we want to skip this node and we want to append this node to our resulting list. Then if x.val is not equal to x.next.val, then we can just append x to our resulting list. Let's go over the pseudocode. So we're going to create the following variables. The first one is the sentinel head of the resulting list. And then we have stail, the sentinel tail of the resulting list. Initially as head, and also a node, our current location inside the input list. Initially head, the head of the input list. Then while node is not equal to null, this means we still have nodes to process. We will check for duplicate nodes first. We want to skip all of the duplicate nodes. So while node.next is not null and node.val is equal to node.next.val, this means the current node is a duplicate. So I'm going to set node to node.next. This will allow us to reach the last node of any of the duplicate nodes. So for example, if we have 1 and 1, after this loop, it will allow us to reach here. Now, before we append current node to a resulting list, we want to disconnect it. So we're going to save the next node first. So I'm going to create a variable next and set it to node.next. Then we'll set node.next to null, disconnect it, and then we're going to append it to a resulting list. So set stail.next to node, and then set stail to node. Then we can set node to next, continue on our search, and then we can return sHead.next, which is the head of the resulting list. Let's go over the time and space complexity. So the time complexity is O of n, where n is the number of nodes in the input list. We visit each node once, and our space complexity is O of 1 because we just modify the input list. Let's go over the code. So we are first going to create our sentinel head or sentinel tail and our current location. And then while node is not equal to null, we will first skip off the duplicate nodes while node.next is not equal to null and node.val is equal to node.next.val. So we want to skip the node. After this loop, we will reach the last node of any of the duplicate nodes, of the group duplicate nodes. So before we append the current node to our resulting list, we want to disconnect it. So we're going to create a list node, next, save the next node first, and then we'll set node.next to null, and then we're going to append it to our resulting list. And then we're going to move forward to continue on our search. Then we can return sentinel head.next, which is the result of which is the head of the resulting list. Let me know if any questions in the comment section below.